So let's finish out section 1, 2. No more word problems. We're going to get a little bit more technical. We're going to look at a sequence. And a sequence is just going to be a list of numbers, and their fancy term is going to be sequence. We've already worked with them. Up here we were adding 6 each time. Up here we were adding 800 each time. We're just going to come down here where a little bit more formal. We've got these expressions here in algebraic terms, the 4n plus 3, and we want to come up with the first 4 terms. N stands for our natural numbers. So again, just a reminder, the natural numbers start with the number 1 and go to infinity. No zeros, no decimals, no negatives. So I'm going to plug in the number 1, 2, 3, and 4. Nothing fancy here. So I'm going to plug in 1, 2, 3, and 4 into my equation. Again, not doing anything fancy. On these, you wouldn't even really have to show work, and I would be completely fine with that. So for this first one, I would get 7. For the next one, I would get 11. Then I would get 15. And then I would get 19. So that would be my answer. 7, 11, 15, and 19. We haven't seen exponents yet, but exponents do come up throughout the semester. So here's our first example of exponent. We've got n squared. I'm again just going to plug in the first 4 natural numbers. So 1, 2, 3, and 4. So 1 squared minus 1 is 0. 1 squared is 1. 2 squared minus 1 is 3. 3 squared minus 1 is 8. And 4 squared minus 1 is 15. So the answers are 0, 3, 8, and 15. And the last thing is to figure out how many terms are in a sequence that I give you. We actually already saw this when we did the Gauss sum. It is the last number minus the first number divided by what we're skip counting by plus 1. So we already saw that one time. I'll show you how it works up here with A. So I would do 38 minus 23. We're just counting by ones in this case, plus 1. So I'll do that fraction first. That would give me 15 plus 1 is 16. So there's 16 terms. You probably could count this one on your finger and be completely fine. Just count up from 23 to 38. Remember that list does include 30 and 31. The dot, dot, dot is just because we're lazy. That ellipse there is because we're lazy and we don't want to list them all out. All right, I'm going to come back to B and C, but I want you guys to try D here. So why don't you go ahead and pause the video and see if you can give D a try there. I'll try. We've got the formula. There's a formula on the screen too. So try D with that formula, and then we'll go back and work B and C. So let's see how you did with D. If you haven't tried it again, hit pause and give that a shot. 81 minus 3. It looks like we're counting by 3s in this case. These are multiples of 3. So like 15's in that list, 21. And then we do have to add 1 at the end. We never want to forget that. So if we do the 81 minus 3, then divide that by 3, that's going to give us 26. That fraction gives us 26. We have to add that 1 on to give me an answer of 27. Now let's go look at B and C. So B and C are different because they both are going to be using exponents. It's very easy to see that B uses exponents. C is not as easy to see. That's what I'm telling you, and I'm going to work C out. It's a little busy, so I'm just going to erase these other things that we have written up here and let me work C. I know that this is an exponent, it's an exponential sequence because it's not steady counting. We can compare it to D. D is 3 each time, 3, 6, 9, I know it's going to be 12, then 15, then 18, then 21. If I look at C, they are not steady. 1 to 4 is 3, 4 to 16 is 12. They're not the same increment each time. That's how I know it's exponential. The space between the numbers gets bigger and bigger and bigger. with exponents, and if you didn't know this, that's okay. That's what I'm telling you right now. We're going to look to the second number right here. All these numbers can be written as 4 to some power. So for instance, 4 is 4 to the first. 16 is 4 squared. We can check. 64 is going to be 4 cubed, but check that in your calculator. 4 cubed gives you 64. Now I need to figure out what the number 16,384 is. And I'm just going to do some trial and error. I'm going to try 4 to the 5th. I'm just typing that in my calculator. Just keep trying some numbers. And when you get to 4 to the 7th, 4 to the 7th is 16,384. Again, that's trial and error. Don't think big. Usually exponents grow really, really fast, so it doesn't take a very large exponent in order to have a big number. Now, I purposely skipped the 1 over here. You know, I might be thinking she didn't use all of them, and you're exactly right. 1 is kind of tricky to see. That's why I didn't want to start with it. 1 is any number in the base, where that 4 is, to the 0 power. So this is 4 to the 0. 1 can be 5 to the 0, 7 to the 0, 27 to the 0. 1 can be anything with a 0 in the exponent. And you can see B, the one I'm going to have you guys work, has that as well. So our exponent patterns are going to start with that 4 to the 0. Again, I need to use 4 because it was the second number right here. That was the number I'm going to look for. I'm going to use this list down below. And I can use my same formula. Just think about the exponents. The highest exponent is 7, the lowest exponent is 0. We're counting by 1, and then we add 1 to it. That's going to give me 8. You also probably could count on your hands. 0 being your first finger. 2, 3, 4, 5, 6, 0. 1, 2, 3, 4, 5, 6, 7. And that would be 8 fingers on there. So you could just count it up, or you can use that formula. So let's take one more pause for this section and give you a second to try B. I've already got it lined up in those exponent form. So all you have to do is that little subtracting step or finger counting. This one you might not want to finger count because it goes all the way up to 50 there. But go ahead and hit pause and see if you can get that answer for B. Coming back from B, the highest exponent was 50, the lowest exponent was 0, which is count by ones. And we always add 1 at the end, so that's going to give me 51 terms. If you don't want to show work for these, that's completely okay. I know some people, especially with these exponents, they know it's always going to be adding 1 because it's all of them plus the 0 one. So it's all from 1 to 50, so 50 plus that extra 1 at the beginning. So some people find some patterns there that they would rather use in the formula, and that's perfectly okay. On any of these, feel free to rewind and rewatch me explain some of these, or also email me any questions that you might have.